Hello guys, in this video we will put everything together with respect to neural networks. So till this video we have seen everything in bits and pieces. So in our first video we talked about a general architecture and some notations. In my second video I talked about how forward propagation works and have given the detailed equations with respect to that. And in my third video I have discussed about how back propagation works and how we update the weights in order to minimize the cost function, right? So in this video, we'll put everything together so you can treat this as an overall summary of how neural network works. Okay, so let's get started. So let's say we have this neural network architecture. It's again the same thing. Input layer, we'll have hidden layer, one or more hidden layers, and the output layers. And each of these layers will have the weights associated with them. W1, B1, W2, B2, W3, B3, and in the end, we will have our predictions. So these are our predictions, right? So this is how a general neural network architecture looks like, right? Now, what are the steps involved to train the neural network? So first step is to collect and prepare the data set that we want. Okay, based on the number of features that we have, the number of neurons in the first input layer will be decided. Okay, next we have to decide on the network architecture. So when I say network architecture, it will involve multiple things. How many hidden layers we need to have, and how many neurons in each hidden layer, right? How many neurons in each of those hidden layers we need to have. Then other thing we have to decide is what activation function to be used. What activation function to be used at each hidden layer, right? To be used at each hidden layer, and how many neurons we will have in our output unit. So this actually depends on the task that we are training this network on. Okay, so if we are predicting only a single number in the end, one neuron would suffice. If we are predicting multiple numbers, we need to have so many neurons, as many number of outputs that we want. Okay, so these are all some things which we have to decide, and there is no hard and fast rule or there is no thumb rule that for this particular task we need to have these many neurons in hidden layer and there should be so many hidden layers. So there is no hard and fast rule. One thing to remember is, as and when you go on increasing the number of hidden layers and number of neurons in the network, it will try to learn more complex patterns in the data. So that may also lead to overfitting on the training data set, and it may do not well on the unseen data set or test data set. So that's a separate topic for discussion on model complexity or the network complexity, and how do we do that as part of regularization. That will be covered in my separate video. So for now, the first step is to prepare the data set, and then you have to decide on the network architecture. And of course, you can change this network architecture if it's not performing well as you desired on your task. Okay, you can change it anytime. So these are the things. Then, as I told you, we will have multiple parameters, right, which are to be learned, right, in order to reduce the cost function. And in this case of neural network, we will have W1, it will be of shape 4 cross 5, W2 will be of shape 2 cross 4, and W3 will be of shape 1 cross 2. Okay, so this is what I have written here. So W1 will be having 20 parameters, W2 will be having 8 parameters, W3 will be having 2 parameters, and at each layer we will have this bias added, right? So these will be single number, and in the end it will be again broadcasted in the same manner or in the same size to which we are applying the addition on. Okay, so this one you have to keep it in mind. So in total, this neural network architecture will learn 33 parameters. So these are our learnable parameters which we will update in order to reduce the cost function. And at what time we will update them? During the back propagation, right? So that's how we will train the neural network. So once we have these weights created, once we have these weights ready, we need to initialize them to some random numbers, right? We have to initialize them to some random numbers, possibly between 0, 1, or if you want to dive more deeply, you can have the numbers picked from a Gaussian distribution or normal distribution in order to initialize the weights for each of these layers. Okay, so that's how initially the weights are initialized. So if you consider it with the machine learning analogy, we will initialize thetas, right? Theta 0, theta 1, theta n to some random numbers, right? Some random numbers, or even we start with 0. So that's okay. But in this neural network case, if we initialize all the weights, the values of each of the parameters in each layer to 0, we can see that each of these neurons will learn exactly the same thing, right? So if each of these neurons are learning exactly the same thing, there is no point in having multiple neurons in the hidden layer, right? So that's why we have to initialize the weights to some random numbers, and it will be good if you initialize the numbers such that the distribution of those numbers will follow a normal distribution or Gaussian distribution, right? So this one thing you need to keep in mind. So once we have initialized it, we need to decide what the output is. It will be based on our task, and we need to decide on the cost function. Again, this cost function will be decided based on the task for which we are training our neural network. Alright. Once we decide on all these things, the next thing is we do a forward propagation wherein we calculate the activations for each layer, and finally we will calculate the output. Once we have the output, we will compute the cost. Once we compute the cost, our aim is to minimize the cost that we have obtained, right? So what we will do, we will do back propagation, and while doing back propagation, we will update the weights and biases that we have initialized during our neural network architecture initialization. So once we do this, we will repeat the steps 5 to 8 for multiple iterations. So we will repeat this for multiple iterations. So how many iterations? You can try for 100 iterations, 200 iterations, 300 iterations, okay? And at each iteration, you can print the cost value after each iteration. So if you see that after, let's say, 20 or 30 iterations, if the cost is not reducing, you can stop the training. All right. So if you see it is still reducing, you can continue the training till the cost is reduced and it remains the same for multiple iterations going forward. Okay. So this is how you train the neural network. So this is a simple video wherein I have put everything together, which I had covered in bits and pieces. Of course, this is not in detail because I have covered the earlier 3 videos in detail. So hope this is clear for you guys. If you guys have any questions, please reach out to me in comment section. Till we see in the next video. Happy learning. Bye bye.